Welcome. This question says, plot a graph of T, that's temperature in Kelvin, versus particle speed for an ideal gas. Again. Oh well. And here's a grid down here. So this is a graphical question. And what I'm expecting is that you can look at the underlying physics and express them as equations and then rearrange them and end up coming up with a plausible graph here with numbers, axes labeled, and the correct relationship. So there's an awful lot of freedom in this question, which is sometimes a little bit disconcerting to people. So first of all, visualization. I'm talking about the temperature. The temperature versus the speed. So I'm visualizing a little volume of ideal gas, and inside there I'm visualizing a whole bunch of particles. And at a given temperature, you have a given average speed, and there's a relationship for that. I don't remember that relationship. What I remember is that PV equals the number of particles times Boltzmann's constant times the absolute temperature. And I also remember that the pressure is equal to, it's going to be 2/3 the number of particles in a given volume times the kinetic energy, the average kinetic energy, half mv² of those particles. And if I rearrange these, I see that from the top line, N kb times T, and if I move this V over here, I see that that equals 2/3. The N stays there. The V we move to the other side to make PV again, and we have a half m little v², velocity squared. The n's go away, the 2's go away, so I end up with kb times T, Boltzmann's constant times the absolute temperature, is equal to mv²/3. Now, this is interesting in a graph showing T, so T will be vertical versus speed, and speed is little v, which is horizontal. So I want my equation to have the same form, so I'm going to isolate T. So I say T is equal to, well, 1/3 m v² all divided by kb. And now I'm going to do something which, just to highlight something. So T is one of my axes, so I'm going to write T in a different color. And V is one of my axes, so I'm going to write V in a different color. And then I'm going to go back and rewrite this equation. So this equals 1/3 m over kb, and that's multiplied into v². Almost there. This 1/3 is a constant, the mass of the particle is a constant, and kb is a constant, so this is a constant. So I could say, okay, T is equal to, use different color for everything now, a constant times v². Okay, so let the constant equal 1. There's no law saying I can't do that, and it just makes what happens next a lot easier. So I say, okay, let's do a table, T versus V. And so let V equals 0, and 1, and 2, and 3 and 4. And then constant equals 1. So t equals 0 squared, which is 0. And then t equals 1 squared, which is 1. And then t equals 2 squared, which is 4. And then t equals 3 squared, which is 9. And t equals 4 squared, which is 16. And so on. The key point is that I can now go to my graph. I have to put at least 3 points, and I have to draw the curve nicely. And they've got to be linear. I can't just, have a wacky scale. So along the bottom, I'm going to go 0, 1, 2, 3, 4. And then vertically, I'm going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, up to 9. I don't care about not going to 16. It's like I'd soon have a nice simple scale. And now 0, 0 is a point. And 1, 1 is a point. And 2, 4 is a point. And 3, 9 is a point. And so would 4, 16, but it turns out that's beyond the range of my graph. And then I draw myself a nice smooth trace through it. And there we have it. That's what I'm looking for in this type of question. It's uncomfortable because I give you so few numbers to work with. It's uncomfortable because you have to decide what to do with, this complicated pattern of 1/3 m over kb. What do you call that? And the trick is you call it 1 because it's just a constant. Lots of people will tend to they'll want to do a table of t versus v squared because that's what they're seeing in the equation, whereas in fact it asks you for t versus v. So you've got to be careful to make your table match your graph, not your table match what seems to fall out of your equation. This is an important skill. We tend to get focused on equations and sometimes forget the graphical representation of relationships. These say the same thing. One's visual, one's abstract. They are both really important. So I think it's important that you can go backwards and forwards between one and the other, and you're comfortable with that. So there we have it.